guys, hi everyone, welcome to Easy Tech. In the last session, I gave a lecture on characteristics of separately excited DC generator. In this lecture, we'll discuss load characteristics of DC shunt generator. If you draw the diagram of a shunt generator, the armature winding and the armature is connected in parallel with the field. The current delivered from the armature is Ia. The current flows through the field winding is ISH, and the current which is flowing through the load is load current. The generated EMF is Eg, and the internal resistance is Ra. The internal resistance of the winding is Ra. Here one switch will be provided. If the switch is under open circuit condition, the load current value is equal to 0. And one more thing, you can connect one variable rheostat. Here. So in order to get the variable flux, and the field current is varied, and the flux is also varying. Means number of flux lines is increases, or generated EMF is also increases. This is the first step. During this condition, the switch will be under open circuit condition, and this we can say that it is a no load condition. Once the load switch will be closed, after that you can increase the load. So you can increase the load. If you are increasing the load, as load current is increases and Ia is also increases, you should maintain the shunt current should be equal to constant by varying variable rheostat. So flux is maintained as constant. As Ia increases, then armature reaction is also increases. As Ia increases, armature reaction increases. Then the no load induced EMF is decreases to E. And the second drop is as Ia increases, Ra drop increases, then the terminal voltage E0 is decreases to Eg is also decreases. If you draw the characteristics between Vt versus IL, why? Because Ia is approximately equal to IL. Why? Because ISH is very low. ISH is low, not a very, but if you take a 20 amperes is the rated current and 1 ampere is there for field current. So based on its rating, okay, and Ia is approximately equal to IL. So under no load operating condition, I am taking the no load voltage is the reference. What is the first drop? Armature reaction drop. So due to this, the terminal voltage will be decreases, or the no load voltage E0 is decreases to Eg. So this curve is Eg. The drop due to the gap between these two, this line and this line, is drop due to armature reaction. And the second drop is also obtained. The second drop is also produced. The IaRa drop is also, the gap between these two is called the IaRa drop. area drop. So from no load to full load, the terminal voltage is almost constant. The terminal voltage is almost constant. That's why this can be used for battery charging purpose. This can be used for battery charging purpose. And one more thing, for lightning purposes also. Lightning purposes also. And one more drop is also there. The drop reduction of terminal voltage. The field current is decreases, but in this case we are maintaining field current is constant by varying this rheostat. The RF decreases, then ISH will be increases, then the flux is maintained as constant. That means the field current is maintained as constant. In order to indicate the field current, we can place the 1 ammeter in series with the field current and 1 ammeter in series with the load. Okay, these are the applications of DC shunt generator, and this is also very important. And suppose if you are increasing the load beyond E value, what will happen? So why shunt generator? This is also important question. Why shunt generator? Load characteristics. Why the shunt generator load characteristics turns back when overloaded. So what will happen if you see the characteristics? So from no load to full load, the characteristics comes like this, and this point is called the P point. A small drop is produced due to armature reaction and armature resistance drop. This is E naught Vt versus IL. As load resistance decreases, load current increases. I think most of the students they confuse that. Sir, as load increases, what about the load resistance? All the loads we are connecting it in parallel. If the parallel resistance will be increases, that means parallel connection increases, then the resistance value will be decreases. Yes or no? If two resistors, equal resistors are connected in parallel, that is R by 2, three equal resistances are connected in parallel, R by 3, so R by 4, like that. If the parallel connection increases, then the resistance value will be decreases, then the load current is increases. The load current increases. If load current increases, the load current is coming from the armature, and armature reaction is also increases. Armature reaction is also increases. If armature reaction increases, our generated EMF decreases. With this generated EMF, then the terminal voltage is also still further decreases. And it will comes back to this position. If Vt decreases, our load current is also, that means IL will be decreases to this position, and these points are PQ and R. If you project on x-axis, this is the load current 1 and this one is load current 2. So IL1 is greater than IL2 and this is IL3. So IL3. So the generator is overloaded. At this point you can observe the generated EMF is 0. Only this much current is present. That means it is acts as a Yes, generator voltage is 0, some current is present means short circuited, like that. Okay, so that's why the generator should never be overloaded. See the nameplate details. If you are, suppose if the 20 amperes is the rated current, you can apply up to 20 amperes. Okay, and the next characteristics are load characteristics of load characteristics of DC series generator. So this is series field winding is connected in series with the armature. Yes, this one is armature. The field winding is connected in series with the armature, and here the prime mover is driven with some speed n, and the current which is delivered from the armature is Ia, and IL, the current which is flowing through series field winding, is ISC, and the load is connected. As load increases, IL increases. If IL increases, IA increases, ISC increases, phi SC increases, and the net flux, that is, yes, phi SC increases. If phi SC increases, our generated EMF is also increases. Again, as load increases further, generated EMF is also increases further. And if IL is equal to 0, that means under open circuit condition, a small residual flux is present here. Residual flux is not equal to 0, but it is very, very small. If you draw the characteristics, it is a load characteristics, VT versus IA is equal to IL is equal to ISC. This is zero value of current. So initially it consists of some voltage due to the residual flux. After that, load current is increases, then the terminal voltage is also increases. If generated EMF increases means terminal voltage also increases. And if you are considering the two drops, right, one is called the armature reaction drop, and this will drops to downside. And if you are considering the one more drop is armature resistance drop. This is, we are considering the IA into RA plus RSC drop. So this is a characteristics. This is called the characteristics of load characteristics of DC series generator. As load increases, terminal voltage also increases. This can be used as boosters. The major application of DC series generator is used as booster. And the next one is load characteristics of DC compound generator. As we discussed earlier, we have a cumulative compound and differential compound. Cumulative compound and differential compound generator. In a differential compound generator, phi net is equal to phi sh minus phi sc. In this cumulative compound, we have a three types: over compound and under compound and flat compound. In over compound, the terminal voltage is greater than E. In under compound, Vt is less than E. And in flat compound, Vt is equal to E. Okay, based on the compounding level, the net flux is phi sh plus phi sc. If you draw the characteristics, Vt versus Ia is approximately equal to IL Ia is approximately equal to IL. So either you will take a long shunt or short shunt connection for analysis. The current delivered from the armature is Ia, current flows through the load is IL, and this is a shunt current. Here I am connecting a load, and the voltage which is applied across this one is Vt. So I am taking that E0 is the reference here, E0. So if you go for the under compound from no load to full load, the terminal voltage is same. This is a curve for flat compound, sorry, for under compound different. The drop will be minimum, the drop is minimum, the drop value will be minimum. Okay, so you can observe that this is about the under compound machine, and if you go for the over compound, as load increases, see what will happen as load increases, load current increases, Ia increases, the armature current is increases, load current is coming from the armature, Ia increases, Ia and ISC both are same, ISC increases and then phi SC increases, finite value will be increases for cumulative. So flat compound, you can observe, this is for the under compound. If you take a over compound, what will happen? So it will be increases like this. So it will increases like this. This is called the Vt versus Ce over compound. How the poles are designed? So this is called the series field winding. This is shunt field winding. If the current flows through series field winding, it will produces a more flux. If the current flows through shunt flux, the shunt flux is almost constant. So if the compounding level is more, then the series field flux produces more. If the compounding level is less, then the series field flux is also less. Based on that, we are drawing the characteristics. And if you observe, differential compound, so the finite value will be decreases for differential compound DC generator. So it will, the characteristics are comes like this. From no load full load, the value will be very very low. So after that, I am getting the separately excited. So after that, I will get the, yes or no, and separately excited, some more drop is there over under compound. After that, shunt generator. Why I am giving the shunt generator means reduction of field current due to armature reaction and armature resistance drop. So shunt generator. Okay, this is a exact curve of load characteristics of all, and this can be used for lightning purposes. Cumulative compound is used for lightning purposes and battery charging. If you go for the differential compound, as load increases, finite decreases, generated EMF decreases, Vt is also decreases, and this is used in arc furnaces. Or generated, if net flux increases means our generated EMF is also increases, our terminal voltage is also increases. The increasing in terminal voltage will depends on the compounding level. Coming to the differential means the terminal voltage will decreases. As load increases, terminal voltage decreases, and this type of compound generator is used in arc furnaces. And with this, the characteristics of all the DC generators were over. I think you people, or you people are understand this. Thank you guys. We will see in next